All right. Yeah. So today I just wanted to talk briefly about some of the charting features that we've got in LabKey. Some of the key components to making like good sort of presentation ready plots that I think of just as being sort of these core components are, well, first off, you need sort of structured, unified, and complete data. So you need your data to sort of be cleaned and formatted in a way that you can distinguish your replicates and highlight your subgroups and stuff like that. You need it to be unified. So if you're making longitudinal plots, you probably want to combine multiple experiments and various conditions. And you need your data to be complete. So you need all your metadata without missing values. You need to have your replicates for statistics and kind of having the right experiments available to do your plotting. Um, so of course, this is basically what you're using LabKey for, is to keep your data structured and managed and unified. So I'm not going to dig into this too much, just to say that, it's nice to sort of leverage your structured data to be able to quickly make, beautiful plots. And also do some of the cool like AI things that Origin is working on. So lots there. The other part of making plots that I think is pretty important is the software. So you want your software for plotting to be both reproducible. So you want to be able to kind of run that same pipeline many times on different types of data without having to make tons of changes. Flexible. So you want to be able to make lots of different types of plots. And this is where, using sort of programmatic languages can be very helpful if you want to make things like heat maps and cool stuff like that. And then I also think it's important to sort of adopt a professional visual style. So if you have an aesthetic style that is particularly good, there's actually genuine value in adopting a cohesive visual style that can help you emphasize the sort of important aspects of your data. So here I've got just some example plots from a book called The Fundamentals of Data Visualization, where the author highlights the difference between, a perfectly fine plot versus a plot that's sort of distracting or ugly, versus one that's bad, like visually confusing, does not sort of give the right message. And then, of course, one that's just wrong, doesn't have the right data at all. So we can probably all avoid this last scenario, but adopting just a clean, sort of straightforward visual style can really go a long ways towards having your audience understand the story that you're trying to convey with your data. Um, so given these three software points, first I thought I'd just talk about reproducibility of plotting in LabKey. So when you're in LabKey, you've added your structured data to LabKey. You've got all your variables, your metadata that you're interested in. These are in your grid view. One thing that you can do is save that grid view. So you've got your data, you save your view, and that grid view then becomes something that's available for plotting. So any data that you're surfacing in your grid is what you can actually plot using LabKey's charting features. One of the things to note is, of course, you can add like filters to grid views, and you can sort them in various ways. But so if you want to, filter a subset of your data, say, oh, filter down to just these experiments, that's what's going to show up when you actually do your plotting. And because you can save your view here, so you just go to views, save. In this case, I saved a custom grid view for plotting. You can just sort of instantly sort of regenerate those filters on whatever new data set that you've brought into LabKey. Um, Now you can always just download your filtered data set like as a CSV file and make some plots in R or Python or whatever, whatever plotting software you like to use. But LabKey also has some pretty cool sort of built-in charting capabilities. So you can hit this create chart button here, and that'll take you into just a create chart wizard, which just supports several different kind of standard types of charts. So right now we support bar charts, box charts, lines, pies, and scatter plots, all of which are pretty decent. And so given those, you know, if you've got new data, you can just basically filter for that data and then try to run one of these plots on that. So once you're happy with the structure of the data that's in your plot, you can start pulling in aesthetics to make simple, sort of effective visualizations. So we've also got several different sort of aesthetic options within LabKey. You can customize your plot title and your axis labels. That makes sense. So you can kind of change these to say whatever they are, regardless of what your data is. You can also subset your data into sort of logical groups and distinguish those groups by point shape or color or line type. So here we've got a batch ID where I've just split samples into various batches, and then I'm also coloring them different colors and giving them different points to just sort of show these different batches are showing up. And then you can show aggregate points. So in this case, I'm actually showing this is a mean value of multiple replicates. And you could add error bars to this as well using standard error or standard deviation. But in this case, I thought it looked a little cleaner to leave those off, so I just left them off. But these are just sort of some of the basic aesthetics that exist in LabKey that you can apply to your various things. And so with that, I just wanted to kind of share a couple example plots that I generated in LabKey. So this is that scatter plot again. You can also, of course, make these pie charts, which are really nice for just viewing sort of the sum of all of the data or things that you have in LabKey. As long as you've got the right data, you can make like scatter plots or these nice bar charts. And so again, I'm just sort of touching on a couple of the basic features that you can do. I just wanted to share a few example visualizations, but there's a lot more to dig into there.